this topic is about understanding how to differentiate from first principles. You need to be able to differentiate expressions involving fractional and negative indices using differentiation from first principles. Also, that the process of differentiation gives the gradient at any point on the curve f of x. So let's go through the theory of this using the example of y equals x squared. So if y is equal to x squared, then the y is a function in terms of x. Okay. And if I want to find the gradient of a tangent at a point x, then that x coordinate is obviously x, and the y coordinate will be f of x. So I want to find the gradient at the tangent on the curve x at the point f of x at the point x, which means I need to draw a tangent to the curve at the point x. So if I were to draw a tangent, this is my gradient function. So I will call this my actual gradient function. So this will help me to find the gradient of any point on my curve f of x. Okay. However, obviously we don't have the theory to do this now. So the way that we can actually find a gradient using the knowledge that we have at the moment is coordinate geometry, which means I need to find another point on the curve. Let's put it here. And then I know that this point is h away from x, which means the x coordinate will be x plus h, which means the y coordinate of this point will be f of x plus h. Then if I were to draw a line going through the coordinate with x coordinate x and x plus h, then that would be an approximate. So this will be an estimated gradient function, which obviously is not the exact gradient that we want, but it's a rough guess using knowledge that we already have. Estimated gradient function. Okay, so let's use our knowledge to find the estimated gradient function. So the estimated gradient function we normally use coordinate geometry, so it's going to be change in y over change in x. Now, the change in y is this, which is obviously f of x plus h take away f of x. So difference between those two terms. And the change in x is obviously this part, which is x plus h take away x. Now if you simplify this, x plus h into the, remember y is equal to x squared, so that is the same thing as x plus h squared take away x squared. Now the x plus h squared we get by replacing the x in y equals x squared with x plus h. All over x plus h take away x. Now you can clearly see that the x and the negative x will cancel out here. Let's expand the top. When we expand the top, we get x squared plus 2 lots of hx plus h squared take away x squared all over h. Now you can see again the x squared and the negative x squared there will cancel out. So all you're left with is 2hx plus h squared over h. And you can see that there's a factor of h that can be cancelled out in the numerator. So you end up with 2x plus h. Now obviously we've chosen h to be here somewhere there. Now if we make this h get closer and closer to the first coordinate, then our estimated gradient function will get closer and closer to our actual gradient function. So what we need to do is make sure this gap here where h is the smallest. So what we need to do is make it get closer and closer to 0. As h gets closer and closer to 0, so the gap between x and x plus h gets smaller, then you know that what you've got, the expression that you've got there, which is 2x plus h, will get closer and closer. Because h is getting closer and closer to 0, the h will disappear. So all you'll have is 2x. Okay, so the 2x plus h gets closer and closer to 2x. That means the gradient function is limit h tends to 0. So as h gets closer and closer to 0, for the expression 2x plus h is equal to 2x. Okay, which means the gradient function is equal to 2x, e.g. or i.e. the gradient function is labeled as f dash of x is equal to 2x. That means for any point on the curve y equals x squared, you can find the gradient at any point by substituting to the function 2x. Okay, that would be it. Don't need to do the process of differentiation from first principles using diagrams. What you can do is use this formula. Now this formula here is available to you in the formula booklet. So anytime in the exam it says differentiate from first principles, you need to use this formula, which is what we've done in the diagram. But I've used the diagram to demonstrate the theory, but we want to just use the formula straight away in an exam. Okay, so that make sure you know where it is in the formula booklet, or you memorize the formula and then you can work it out. Okay, so if you were given this question in the exam, it will look like this. Differentiate f of x is equal to x squared from first principles. So that means you need to write the formula. The first line is always the formula. So I would write f dash of x is equal to limit h tends to 0 of f of x plus h minus f of x all over h. For every single line of the working out, I will have this limit h tends to 0 until I can make h go towards 0. Okay, if f of x plus h is in the function, you replace x with x plus h. So I get x plus h squared minus f of x is just x squared. So just remember again, I'm just going to write it here. If f of x is equal to x squared, then f of x plus h is, we have an x there, we replace it with instead x plus h. So it's the same thing as x plus h squared. Okay, going back to the left-hand side, all over h. Okay, I've got a bracket that I need to expand. This line still needs limit h tends to 0 because I haven't done anything with that. If I expand this bracket, I get x squared plus 2 lots of hx plus h squared, take away x squared over h. I can clearly see the x squared is cancelled out. So I've got limit h tends to 0 2hx plus h squared over h. I can cancel out a factor of h in the numerator by dividing it by h. So I end up getting 2x plus h. Okay, now this is where I can't simplify anymore. So now I need to make h tend closer and closer to 0. So get closer and closer to 0. So what happens to the expression that I have left over? So as h gets closer and closer to 0, 2x plus h gets closer and closer to 2x because the h disappears because it's very close to 0. Therefore, f dash of x is equal to 2x. And that is it. And it's the same thing as saying the gradient function is equal to 2x. F dash of x is equal to 2x. And this is the expression you use to find the gradient at any point on f of x. A word about notation. So the gradient function is equal to f dash of x. So anytime I talk about the gradient function, I'm talking about f dash of x. F dash of x is the same thing as writing dy over dx, which means the derivative of y with respect to x. the derivative of y with respect to x. And it's also the same thing as writing y dash, so the derivative of y. So in that case, the formula can be of these form. The first one is the one in the formula booklet, which looks like this. I'm just copying out the formula from from above. Or it can, instead of, if you had y is equal to x squared, then instead you could write dy dx. Instead of writing f dash of x, you could write dy dx is equal to limit h tends to 0 of f of x plus h minus f of x over h. Or you can have y dash. They all mean the same thing. Y dash is equal to limit h tends to 0 of f of x plus h minus f of x over h. They all mean the same thing. So derivative of x, gradient function, f dash of x, dy dx, y dash, all the same. Let's go through some examples of this. So no diagrams anymore, using the formula. Okay, differentiate f of x is equal to 2x minus x squared from first principles. Okay, so first line is always the formula. Limit h tends to 0 of f of x plus h minus f of x all over h. So if f of x is equal to 2x minus x squared, then f of x plus h, I'm replacing everywhere I see an x in my expression with x plus h. So it'll be 2x, 2 lots of x plus h minus x plus h squared. So this is the same thing as limit h tends to 0 of 2 lots of x plus h minus x plus h squared. Take away f of x, which is equal to 2x minus x squared, all over h. Okay, so limit h tends to 0 of 2x plus 2h minus, if I expand x plus h squared, I have to subtract, that means I need to subtract x squared minus 2 lots of hx minus h squared. So that's what I get from the first two terms. Take away 2x plus x squared, because the minus times negative x squared gives me positive x squared, all over h. Now I can clearly see the x squared here and the x squared there will cancel out. If I collect like terms together, I end up getting something else that cancels out. I can see the 2x, the negative 2x will also cancel out. So what I'm left with is 2h minus 2hx, take away h squared, all over h. Again, I can divide the numerator through by h. So I end up getting limit h tends to 0, 2 minus 2x minus h. Now at this point I can't simplify anymore, so I need to write as h tends to 0, what happens to this expression? 2 minus 2x minus h tends to 2 minus 2x, because the h disappears because it's getting closer and closer to 0. Therefore, f dash of x is equal to 2 minus 2x. Next example. Okay, so differentiate f of x is equal to x plus 1 squared from first principles. So again, my notation will be f dash of x is equal to limit h tends to 0 of f of x plus h minus f of x all over h. If f of x is equal to x plus 1 squared, f of x plus h, replace x with x plus h, then I get x plus h plus 1 squared. So it's equal to limit h tends, remember always limit h tends to 0 at the beginning. If you miss it out, you might lose a mark. So x plus h plus 1 squared, take away x plus 1 squared, all over h, which is equal to limit h tends to 0. If I expand x plus h plus 1 squared, I get x squared plus hx plus x plus hx plus h squared plus h plus x plus h plus 1. From the second squared, which is x plus 1 squared, I get x squared plus 2x plus 1, and I'm subtracting this because there's a subtract in the middle, all over h. Now let's see if something's cancelled out. X squared, take away x squared because there's a takeaway here. There's a takeaway here, you can see. Let's swap that out. Okay, positive, I get positive 2x in the first bracket and negative 2x. So these will cancel out, the 1 with the 1 there. So all I'm left with is limit h tends to 0 of, I get 2 lots of hx plus h squared plus 2h over h. If I cancel one of the factor of h at the in the numerator, I end up getting 2x plus h plus 2. I can't simplify anymore. So as h tends to 0, 2x plus h plus 2 tends to, the h will disappear, so I'm left with 2x plus 2. Therefore, f dash of x is equal to 2x plus 2. Okay, next example. Differentiate y is equal to x cubed from first principles. So because y is equal to, I'm going to use dy dx here. So dy dx will be limit h tends to 0 of f of x plus h minus f of x over h. So where f of x is equal to x cubed, then f of x plus h will be equal to x plus h cubed. So that will be equal to limit h tends to 0 of x plus h cubed minus x cubed all over h, which is limit h tends to 0. If I do x plus h times x plus h, I get x squared plus 2hx plus h squared times x plus h minus x cubed over h, which is limit h tends to 0 of x cubed plus x squared h plus 2hx squared plus 2h squared x plus h squared x plus h cubed minus x cubed all over h. I can clearly see the x cubes will cancel out. And if I collect the like terms, I end up getting 3x squared h plus 3h squared x plus h cubed over h. And if I cancel down a factor of h to the top, I end up getting 3x squared plus 3hx plus h squared. Can't simplify anymore, so as h tends to 0, 3x squared plus 3hx plus h squared will tend to, now the h squared term will disappear, but the 3hx, because h is getting closer and closer to 0, the 3hx will also disappear. So all we're left with is the first term, which is 3x squared. So therefore, f dashed of x is equal to 3x squared. Okay, next one, y is equal to 1 over x. So because it's y, I'm going to do dy dx. So dy dx is equal to limit h tends to 0 of f of x plus h minus f of x over h. Now, if f of x is equal to 1 over x, then f of x plus h is equal to 1 over x plus h. So which means limit h tends to 0 of 1 over x plus h minus 1 over x all over h, which is equal to limit h tends to 0. I need to cross multiply, so I get x over x times x plus h minus x plus h over x times x plus h. If you can't clearly see that, all I'm doing is multiplying top and bottom by x here, and multiplying top and bottom here by x plus h. Okay, all over h. So what I end up getting is x take away x take away h. So and then at the bottom I end up, because this is a fraction divided by a fraction, sorry, a number divided by a fraction, fraction divided by a whole number, it becomes h times x times x plus h. Okay, so all you're left with is, oops, this is not good. I made a mistake there, which is your mistake you will make as well. I've forgotten the limit h tends to 0. So limit h tends to 0 of x take away h from the numerator part. And then denominator we have x times x plus h. So I'm glad that mistake did happen, because it will happen in an exam. So limit h tends to 0 minus h over h x times x plus h. Then you can cancel out a factor of h in the top and bottom. So you get limit h tends to 0 of minus 1 over x times x plus h. And again, you can't do anything more than that. So at this point, you say as h tends to 0, what is happening to this expression? Minus 1 over x times x plus h will tend to what? So if the h tends to 0, then it's the same thing as minus 1 over x times x, which is equal to minus 1 over x squared. Therefore, f dash of x will be equal to minus 1 over x squared. Therefore, if you want to write it in index form, it's the same thing as minus x to the minus 2. Okay. Next example, differentiate y is equal to root x from first principles. Again, because it's in terms of y, I'm going to write it as dy dx, which is the derivative of y in terms of x, is equal to limit h tends to 0 of f of x plus h minus f of x all over h. If f of x is equal to root x, then f of x plus h is equal to root of x plus h. So it's equal to limit h tends to 0 of root x plus h minus root x all over h. Okay, now I need to get rid of the square roots. So it's just like rationalize the denominator, I need to multiply the top by root x plus h with the opposite sign in the middle. So plus root x. But obviously that means I need to multiply the bottom by the same. Okay, so when I do that, I get limit h tends to 0, or root x plus h times root x plus h will be x plus h. So I get x plus h at the top. And then the middle terms cancel out. So all I'm left with is negative root x times root x, which is negative x. All over h times root x plus h plus root x. And you can clearly see that limit h tends to 0, the x and the minus x cancel out. So all you're left with is h over h times root x plus h plus root x. The h's will cancel out, so all you're left with is limit h tends to 0 of 1 over root x plus h plus root x. Can't simplify anymore, so as h tends to 0, 1 over root x plus h plus root x. So if h gets closer and closer to 0, root of x plus h will get closer and closer to just root x. So it's going to be root x plus root x, which is the same thing as 1 over 2 root x. Therefore, f dashed of x is equal to 1 over 2 root x which is the same thing as writing half, because you've got half there, x to the power of negative a half, because root x in the denominator and root of x is obviously a half, so we root of x, root negative half, x to the power of negative a half. So that's the answer in index form. Okay, what is f dash of x? So f dash of x is the derivative of f of x, or you can also call it the gradient function of f of x. It tells you the gradient of the tangent at any point on f of x. Okay, so what you have, if you have f of x, you can use it to find the derivative function, which is f dash of x, and then you can use that to find the gradient of any tangent at any point on f of x. Okay, so let's answer some questions so you can understand this. Okay, it says find f dash of 3 when f dash of x is equal to x squared minus 4. So if I'm trying to find f dash of 3, that means I need to just substitute 3 into this expression for f dash of x, which is a gradient function. 3 squared minus 4, which is 9 minus 4, which is 5. So what does this tell me geometrically? This is the gradient of the tangent to f of x at x equals 3. So the gradient of the tangent to f of x at x equals 3 is 5. So the gradient at that point is 5 at x equals 3. Was A. Let's do B. Find the gradient of the tangent at x equals negative 2 on the curve f of x when f dash of x is equal to 3x plus 2. So I'm trying to find the gradient, then I need to use the gradient function. So if f dash of x is equal to 3x plus 2, then f dash of negative 2 will be equal to 3 times negative 2 plus 2, which is negative 6 plus 2, which is equal to negative 4. Okay, so gradient of tangent at x equals negative 2 is negative 4. C. Find the gradient of the tangent at 3, 9 on the curve f of x when f dash of x is equal to 2x. So we're trying to find the gradient at this point, but because the gradient function only involves the x, we only need to substitute the value of x. So at 3, 9, the value of x is 3. So that means we're working out f dash of 3, which is 2 times 3, which is equal to 6. Therefore, gradient of the tangent at 3, 9 is 6. Okay, let's do the next question. The point A with coordinate minus 2, minus 8 lies on the curve with the equation y is equal to x cubed. At point A, the curve has gradient g. So the first thing I need to write down is g is the gradient, so the gradient f dashed of negative 2. Okay, so it's the gradient at negative 2. X equals negative 2. Show that g is equal to limit h tends to 0, 12 minus 6h plus h squared. Okay, so normally the formula is f dash of x is equal to limit h tends to 0 of f of x plus h minus f of x all over h. But we're trying to find g, which is f dashed of 2. So if we replace x with negative 2, then we get f of negative 2 plus h minus f of negative 2 all over h. Now remember, f of x, the function is x cubed. So f of negative 2 plus h is equal to negative 2 plus h all cubed. And f of negative 2 will be negative 2 cubed. So if we replace limit h tends to 0, if we replace f of negative 2 plus h with negative 2 plus h cubed, minus negative 2 cubed all over h. Now, if we expand negative 2 plus h times negative 2 plus h, you end up getting limit h tends to 0 of negative 2 times negative 2, which gives you 4 minus 4h plus h squared. So all I've done is expanded minus 2 plus h times minus 2 plus h times by minus 2 plus h. Negative, take away negative 2 cubes becomes plus 2 cubed, which is 8 all over h. If we continue expanding, it becomes limit h tends to 0. From the first, we get negative 8, 4 times negative 2, plus 4h, plus 8h, minus 4h squared, minus 2h squared, plus h cubed, plus 8, all over h. I can clearly see the minus 8 and the positive 8 cancel out. So if I go here, you get limit h tends to 0. 4h plus 8h gives me 12h. And then minus 4h squared minus 2h squared gives me minus 6h squared plus h cubed all over h, which is limit h tends to 0, 12 minus 6h plus h squared, which is what we wanted. That was part A. Part B, it says deduce the value of g. So g is, basically if you want to find g, is we have to find out what happens as h tends to 0. So as h tends to 0, then 12 minus 6h plus h squared tends to, because h squared gets closer and closer to 0 and 6h gets closer and closer to 0, we get that this tends to 12. Therefore, g, which is equal to f dashed of negative 2, is equal to 12. Okay, and the last example, f of x is equal to ax squared, where a is a constant. Prove from first principles that f dash of x is equal to 2ax. So f dash of x is equal to limit h tends to 0 of f of x plus h minus f of x all over h. Now f of x is equal to ax squared. So f of x plus h is equal to a times x plus h squared. So it's the same thing as limit h tends to 0 of a times x plus h squared minus ax squared all over h. So if I expand x plus h squared and then multiply it by a, I get ax squared plus 2 lots of ax h plus a lots of h squared minus the ax squared from the term at the end all over h. Ax squared and negative ax squared cancel out. And then if you divide everything through by h, you're getting 2ax plus ah. I can't simplify it anymore. So as h tends to 0, 2ax plus ah tends to 2ax, because the second term cancels out. Therefore, f dashed of x is equal to 2ax.